Hello student, welcome to the online tutorial session. Today we will discuss about the database management system architecture. Okay, so the DBMS designs depends upon its architecture. The basic client-server architecture is used to deal with a large number of PCs, web servers, database servers, and other components that are connected to the network. So client-server architecture is consisting of many PCs and a workstation which are connected via a network. Number two, the DBMS architecture depends upon how the user are connected to the database to get their request is done. Okay, so from this picture you are able to understand the DBMS architectures are of three types. Okay, that is one-tier architecture, two-tier architecture, and three-tier architecture. Okay, because number of users, this classification is done, and depending upon number of user, it is using this database management system. Okay, if there is a multiple number of users are involved in there, then we will not consider the the single tier architecture. That point of time we will consider the another two-tier or three-tier architecture. So let's first talk about the tier 1 or first tier architecture. So in this architecture, the database is directly available to the user. It means that directly one central database that is there, that is directly accessible by a single user. It means the user can directly sit on the DBMS and you don't use it. They don't need a request. That is client server system is something like that. Okay, there is a main server is there, and there are many other clients are there. Okay, they need to send a request. Client need to send a request to the server to get the information. So in a single tier architecture, what will happen? It can directly send a request. Don't need to go via some other application program, something like that. They can retrieve the information. Okay, any changes done here will directly to be done on the database itself. So suppose a client is making any, or user is making any changes, so it will be directly reflect to this central database. Okay. In case of one-tier architecture, it is used for the development of the local application, whereas the programmers can directly communicate with the database for the quick response. So only this kind of this type of architecture is designed for the development purpose of a local application program that is depend upon this server. Okay. Now start with the second tier architecture. So this second tier architecture, this is the architecture for the second tier. If you see, there is a one server is there and another this client. Under client, the user and application programs is there. But before in this one tier architecture, directly client is there, one server. There is no application program is there in between. But in case of two tier architecture, there is under the user, there is a two part. One is client or user, another is application. Through the application program, they are sending their request to the server. So let's see, in two-tier architecture is same as a basic client server. In this two-tier architecture, application on the client can directly communicate with the database server through the site. These are actually the OBC, JBC, these are the so there. User interface, the application program. So user actually uses this interfaces, that is the application program, to communicate with the final database, as you can see from this in this database. The server side is responsible for provide the functionalities like query processing, transaction management. To communicate with the DBMS, client-side application is established, so this is connected to the server side. So I'm using that. There is a main difference between a tier 1 and tier 2 is, in case of tier 2, one application program has been built or set up, so that the user can directly interact with the server. But in case of tier 1, there was no such application program is developed. Okay. Now coming to the three-tier architecture. Okay. So in case of three-tier architecture, contains another layer between the client and the server. This architecture, client cannot directly communicate with the server. The application on the client end interacts with the application and server, which are further communicate with the database system. So end user has no idea about the existence of the database beyond the application server. So if you look at the picture, see, previously in 2-tier there is a application program. In only after user there is a application program. Through the application program, server is actually interacting. But here in the 3-tier architecture, under a server, one application program is developed in the server end also. So application program of a client end will send the request to the application program to the server end, and then the server application program directly interact with the database and then fetch the information. So in this way there is a 3-tier, 1-tier, 2-tier, 3-tier. The user cannot directly access the DBMS. So what is the difference between 2-tier and 3-tier architecture? In 2-tier architecture there is a one interface, that is from that application program directly can interact with the server. But here in the 3-tier architecture, the user and application program interacts with the server and application program. Then server and application program will directly interact with the server, that is the main server or database. Okay, so from this there is a one concept is there that is very important coming to your question paper, that is describe the 3-schema architecture. Okay, that is a very important question, very important question. So what is actually this 3-schema architecture? So the 3-schema architecture is also called ANSI or SPARC architecture. Again I am writing, it is known as ANSI / SPARC architecture, the 3-schema architecture. Okay, so the framework is used to describe the structure of a specific database system. The 3-schema architecture is also used to separate the user application and the physical database. Okay, so the 3-schema architecture contains 3 levels. Okay, there are only 3 levels, that's why it is known as 3-schema, because there are 3 different levels is there. What are actually these 2 levels? Okay, there is a database. Okay, above this there is a internal level. Okay, that is known as the internal schema. Then next level is a conceptual schema, and it is known as conceptual level. Okay, and then there is an external schema, that is the external level. Okay, in this 3 level it is divided. Okay, so in the diagram what actually we will have to explain all those levels at a time. Okay, first we will discuss about those schemas and everything first. So in this DBMS architecture, mapping is used to transform the request and the response between the various database levels. What is mapping is, there is a one-to-one mapping, many-to-many, 0-to-0, many-to-one, one-to-many, okay, one-to-one. There are different kind of a mapping is there, that is from one request can be send it to multiple ports, or from the multiple port it can be answered by using only single port. These are actually the known as mapping. From one from one I can send the information to multiple port. Okay, from one, or from multiple port, one can be from one to one. This can be information can be sent. This is known as the mapping. Okay, so mapping is not good for a small DBMS because it takes more time. In internal and conceptual mapping, it is necessary to transform the request from external level to conceptual schema. And in conceptual or internal mapping, DBMS transfer the request from conceptual to internal level. So what is the first level? The first level is known as the internal schema. Internal schema, or you can write down this as a physical schema. It is the lowest level of data abstraction. So before going into further, so you need to know what is the data abstraction. Okay, so data abstraction is actually in DBMS, the abstract or hides from the user is a manner in which the actual data is stored or accessed. That is known as the data abstraction. How actually data are being stored or how actually it is being accessed. Okay, so this information are not available to the user. So this is known as the data hiding, or you can also data abstraction. So take an example of a switchboard. Okay, only to switch on the fan or switch on the light, only we need to on this, we need to press the switch. Okay, afterward in the switchboard, so behind the switchboard, what mechanism is going on, do we need to know? No, we don't bother. We just, whenever we want the fan, we just put a switch on. So that is known as abstraction, that whatever phenomenon of processing or everything is happening, we are not aware of it. So this is known in the physical schema or in the internal schema. So this is the lowest of level of data abstraction. This schema describes in details how the raw data is actually stored at a byte level using the complex low-level data structure. It is also described the access part of a database. Now comes to the next conceptual schema, that is a conceptual schema, or you can say a logical schema. Okay, so this in this next higher level of data abstraction, this schema is used by the database administrator to describe what data are to be stored in the database and what are the relationship between this. Suppose I am storing student details, I am storing, again I am storing marks, again I am storing payment. So we have to, what kind of a data we are storing and how these three tables are interrelated. This phenomenon we need to describe about what kind of a data we are storing. It is a textual data or it is a graphical data. What kind of a data we are storing, and actually how this data that are stored in the table, how those tables are interlinked between them. Okay. So hence the entire database is described in the terms of relatively simple and easy to understand structure like database table, keys, indices. Okay, so this describes the relationship between the different data stored in the database. Now comes to the third one, that is the external. This is the third one, you can say the external level. Okay, so external level actually it is for the, it is a high level, this is the physical layer is a low level of data abstraction, and this external is the high level of data abstraction, because there is a limited view of a table, is a view 1, it is view 2, it is view 3, and here is the user 1, user 2 and user 3. Whatever user 1 is able to view, 2 is not that, because there is a criteria and everything. Whole database cannot be seen by a user. Okay, only just an instance of a table is shown to the user, because whatever query is raised by the user, depending upon this, only that part of this query answered, it is shown to the user. Okay, so view or the external, this is the highest level of data abstraction. This schema deals with the way particular user application programs view the data from the database. Majority of the user will not require to access the entire database, but it will be concerned with only the part of the data in the database. Accordingly, different user-friendly views of the database are defined. Okay, so it is a very, very important question. I hope this thing is clear to you. So thank you, student. I'm ending my lecture over here.